In the last video, we read in some data. In this video, I would like to expand on the idea and show you how we could run some queries inside Apache Spark. I said this in a few videos, but let me state it again here. The purpose of this video series is setting you up with a working Hadoop and Spark pseudocluster so you can start exploring those frameworks on your own. This is not an in-depth Spark tutorial, although it is a good idea for a next video series. However, I still would like to show you the very basics of how to wrangle your data in Spark once it is ready. So let's jump straight into the terminal. And of course, I gotta log in as the Hadoop user again. All right. And as always, we gotta make sure that our Hadoop cluster is actually running. So let's say Hadoop bin, sbin start dfs.sh. Now we wait for the nodes to start. Next, we're going to start the Yarn resource manager. And just make sure that everything is working. Now let's check out the Yarn web UI. So localhost :8088. This works, and we have one active node. Perfect. All right. So we have everything working. Now let's open an interactive PySpark shell. So I will increase the size of this terminal. All right. So let's open this up. So we say spark bin PySpark. And then we're just going to say master. We want to connect to the Yarn resource manager. We're going to use the dev queue. And the name of our application will be query_application. All right, hit enter. Now it's loading. And all of this should be familiar by now. We tell Spark that we would like to create an interactive PySpark session. It should connect to Yarn. We want to work with it on the dev queue, and the name of application should be query_application. Now it's loading. So we are now greeted with the PySpark shell, and we're going to read in the Titanic dataset. So Titanic equals spark.read.format CSV. And by the way, if you've got to write a very long command, you can just break lines with the backslash. So option is header true. Then we say option separator is a comma. I'm going to add another option here. So I'm going to say infer schema is also true. And then I'm just going to load the data from HDFS. So titanic.csv. All right, so it's loading. And it is now loaded into a Spark data frame called Titanic. Notice how I added another option to our code. Here I added the option infer schema and set that to true. This way, Spark will try to figure out the correct type for all columns. You can now use methods on that data frame to start interacting with it. So first, let's have a quick peek into our data by saying titanic.show. Let's say 10 columns and do not trim the columns. All right. So again, this command will show you the first 10 rows. Also, you might be interested in the general schema of that data frame. So you can take a look at it by issuing the following command. You can say titanic.print schema. And as you can see, we have multiple columns with different types, and most of them are actually numeric. So for example, survived is an integer, the passenger class is an integer, age is a double, and so on. So let's run some basic SQL operations. We can select certain columns by using the select method. As arguments, just pass in the names of the columns you would like to select. Note that I always put in the show method at the very end so you can see the results. So let's select only the name and sex of a passenger. So we say titanic.select, and we say name and sex. All right, and then show the first 10 rows. And there they are. So let's do the same, but this time we filter to cases where sex is equal to male. However, before we do that, we must import the functions class from PySpark. So we're going to say import pyspark.sql.functions as f. So I don't have to write the entire thing every time. We can now use a giant selection of functions that were built for Spark data frames. You will see the first one in the following command. So we say titanic.filter, and then we say fcol sex is equal to male. And then we just select name and sex and show the first 10 rows. There it is. Now here we take the data frame and use the filter method. So this is the filter method right there. And inside that filter method, we can write our conditions. This is also where I use the f class. So I use it right there. I say fcol sex equal to male. So fcol sex represents the column sex in our data frame. And we say that this column must be equal to male. So I say equal male. Of course, you could add multiple conditions to the filter method. So let's say titanic.filter. And the first condition, let's put that into parentheses, is fcol sex is equal to male. And the second condition is fcol age is greater than 20. All right. And then we just say select name and sex and show the first 10 rows. And there it is. So this will show us all the males where age is greater than 20. We can also aggregate our data frame in the following way. So we can say Titanic, and let's aggregate our data frame by sex and p class. So let's group our data frame, group by, and then we just enter the column names we would like to group by in a list, and that would be sex and p class. And then AGG, so this is the aggregate function we're going to use. And inside that function, we're going to give a dictionary and say age. We would like to have the mean for that. And for fair, we'd also like to have the mean for that. Now close that dictionary and that function, or method, sorry. And let's show the first 10 rows. And there it is. So we have an aggregation grouped by sex and passenger class. Also, you can always count the rows of a data frame by using the count method. So you could say Titanic.count. And here you can see that the data frame has 887 rows. Again, definitely not big data. You can get distinct rows of a data frame by using the distinct method. Let's say you want to see the distinct passenger classes. So you could say Titanic.select p class .distinct.show 10 false. So as you can see, we have 3 distinct classes on board. Notice that no data has ever been changed. The data frames are immutable. If you really want to change the data frame, you need to override it. So for example, let's say you want to create a new column which equals the logarithm of the fair column. So we want to add that column. We say Titanic equals Titanic.with column. Let's call that column fair underscore log. And that is equal to flog of the column fair. All right, and let's have a look at it. So show, and there it is. So as you can see over there, our data frame now has the column fair underscore log, which is equal to the logarithm of the fair column. In the command, we use the with column command to define a new column. The first argument is the name of the new column or the name of the old column if you want to override it. Then follows the expression that creates that column. Here we use the log function inside the f class. Inside that, we say that we want to use that function on the fair column. We can also join tables, so let's define a small mapping table and load it into HDFS first. So let's create another terminal. So of course I gotta, let's put that down. So log in as the Hadoop user. And now we want to create just a simple CSV file in our home directory. So let's call it pclass_mapping.csv. All right. And let's say pclass and pclass name. So pclass exists in our data frame and we want to join the name of that class to it. So that's why we are creating a mapping file. So we say first is first class, 2 is second class, and 3 is third class. All right, let's exit and save that. And now we need to push that mapping file to HDFS. So execute Hadoop bin HDFS dfs -put, and then select that mapping file and let's just put it into the root directory. All right, that is done. Let's ls into HDFS again, just to be sure. Let's check the root directory, and there is that file. So pclass mapping.csv. Now that file exists in HDFS, and we should be able to read it into Spark. So let's go back into our Spark PySpark session. Okay, so first we read it in as a Spark data frame. So we say pclass_mapping is equal to spark.read.format, just a CSV file again. And we say, let's break lines here, option, header is true. Then we give it another option and we say separator is a comma, and we're gonna infer the schema. So infer schema is true, and then we load it from HDFS. So that was pclass. No, what was the name? Ah, yeah, it was pclass_mapping.csv. All right, that worked. So let's have a quick look at it. So pclass mapping show. All right, there it is. Now that looks good. Now let's left join that mapping to our Titanic data frame. So let's say Titanic is equal to Titanic.join. Now we gotta pass in the table we would like to join. So that would be our Spark data frame, pclass_mapping. Then let's choose the columns to join on. In this case, it's just the variable pclass and the type of join we would like to have. So we want a left join. Right, let's execute that and let's have a look at it. So Titanic.select pclass and pclass name. And let's show that. And there it is. So that worked. Perfect. By the way, PySpark has a very tight integration with pandas. You could convert a Spark data frame to a pandas data frame and vice versa. So for example, if you would like to create a Titanic pandas data frame, you could just say Titanic_pd equals Titanic.toPandas and execute that. Now you could run all kinds of pandas commands, but notice that I'm getting an error message since I haven't installed pandas. So we haven't done that, and that's why it says, hey, pandas must be installed. However, it was not found. You may remember that inside our Spark configuration, we set a single environment variable called PySpark Python, and we set that to Python 3. So we said export PySpark or PySpark_Python equal Python 3. And this will route Spark to our system's Python 3. And there are actually quite a lot of Linux processes that use Python. Hence, it is generally not a good idea to use this Python for personal usage. In a production environment, I would have installed the Python distribution Anaconda and would have pointed Spark towards that Python. However, I didn't do that in our example, so that's why this doesn't work. Alright, so that should wrap up our very short intro to running SQL queries on Apache Spark. Again, this is not meant to be an in-depth tutorial to Spark. Rather, it was designed to get you started so that you can start exploring it on your own.